Like, did you add? Did you subtract? Did you multiply? Did you divide? What did you do to go from the left to the right?
Um,
Like, how do you undo this fraction here?
um, I'm not really sure.
To me, it looks like you multiplied both sides by 10 to clear that 10 on the bottom. That's what I'm seeing. So to me, this is the multiplication property of equality. Does that sound familiar to you?
Yeah.
Okay. So it's kind of the idea is kind of extended here in number C, letter C here. If the measure, if angle A is less than angle B, then angle A plus 90, angle B plus 90, you got this less than as well. So let me just format this a little differently. It's like line one is this, and then line two, they add in this information here. What are they doing to both sides of the equation? What's the,
Um, we're adding 90.
yes, so that would be the addition property of equality. Addition property of equality. Does that make sense?
Yeah.
So, I mean, we could give you an example of subtraction. I mean, if angle A is greater than angle B, you could subtract 10 and subtract 10, and it would also be true.
Hmm.
Is that clear?
Yeah.
All right. So you have two correct. Your intuition served you well on this one. The if you add together the bigger parts, then they're bigger than the smaller parts. So that's perfect. All right, number three, whole greater than the part theorem. Okay, you have this also correct. Um, this part about A being positive and B being positive is important. The sign issue with the addition. If you add two negative numbers, it gets smaller, but positive numbers get bigger. So C is bigger. C is bigger than both B, and it's both bigger than A. That's exactly what you said here. That's perfect. That is completely perfect. So any questions on that?
Mm-mm.
Okay. All right. I don't really like the way 4A is written. So this idea of exterior angles, you typically draw one um one sort of like extension out. Like to me, there's only one exterior angle in a triangle. It looks like the way that your teacher's doing it, there could be more. Not sure. Um, what do you think about 4A?
Um,
Like if we look up here, there's three, there's really three exterior angles. Same down here, it's 6, 7, and 8, and then 1, 2, and 9. Those are like all exterior. 11, 10, 11, and 12 are interior. Maybe that's a better way to look at this. The interior angles are 10, 11, and 12. The exterior angles are everything else.
wouldn't
One,
one,
go ahead.
sorry. Wouldn't 1, 4, and 7 be the vertical angles?
They are, but they're also kind of exterior, kind of. I don't really know how to answer this truthfully because like my interpretation of it has always been a drawing like this,
Okay. I
but
have a
I'm not.
definition.
Yeah, let's go
So
with.
the definition right here says an exterior angle of a triangle is an angle that forms a linear pair with an angle of the triangle.
Okay, so that would answer our question. And that's a better. That's a better. Sometimes I do learn stuff, which is what you just said there. So yeah, 2 and 9 work because they make linear pairs. And you're right. So the 1, 4, and 7 are vertical angles. Does that look good to you now?
Ye yeah, yeah, yeah.
Okay. All right. So part B, if angle 1 plus angle 7 equals 115, probably do need the drawing here again. 1 plus 7 equals 115. What does angle 4 equal? So we know that angle 4 equals what other angle? You kind of already alluded to that.
Or 4 would equal 65.
Nope, nope, 4 is equal to 11. And it might be 65, but we're not sure yet.
Oh,
Is that okay? The vertical angles?
well, so the question is asking what does angle 4 equal?
We're going to get to its actual angle measure. I'm just asking if you're okay with this right here.
Oh yeah, yeah, I know the vertical angles.
Okay. And then what are angles 1 and 7 equal to in the
1 and
drawing?
7 are equal to 12, angle 12 and angle 10.
So we can really say angle 10 plus angle 12 equals 115. So these two angles here equal 115, which means the third angle in the triangle makes it add up to 180. So you were
Mm,
right. I don't know if you had the right reasoning, but sometimes it's okay to just put the right answer down. Is that okay?
yeah.
All right. Now I presume that the way this is written is you're sort of looking at them independently. So like C has no bearing on, or B has no bearing on C. So if angle 6 is 120, let's grab the drawing one more time. Okay. If that's 120 degrees, sometimes it's good to label the other ones like, okay, that's 60, and that's as far as we can go, which means that these two angles, what do they have to add up to for the triangle?
11 and 10,
Yep. What do they add up to in terms of the triangle? We know that this one's 60,
120.
120. So that's actually called the exterior angle theorem. Did you guys talk about that?
Yeah.
The exterior angle equals the sum of the non-adjacent interior angles.
Um, Here it says the exterior angle theorem is an exterior angle of a triangle is greater than either remote interior angles.
Yeah, I mean, but it also equals the sum of these, but yeah. So can angle 11 equal 121? The answer is no, because the sum has to be 120. So how can these two angles, how can these two angles be 120 if one's already 121?
Mhm.
All right. Any questions on that before we move to 5?
Um, so for that one, the answer would be no, it has to be, I
It
mean,
has
no,
to be less than 120.
okay.
And it's odd that your book doesn't use the M measure angle 11. It's a little odd. Like usually you can't just say angle 11, you have to say the measure of angle 11. Okay. Did you guys talk about the three right triangles in this, or just did you look at it as anything else?
I'm sorry. Um,
Yeah, hang on just. All right. What I was asking you, Hudson, is did you guys break this up into three triangles or not?
I didn't do this with the class.
Right, but any notes on that? Because there is a whole like section in your book typically on small, medium, and large triangle.
Oh, like, is there a chapter
There
on it?
will be, and I just was wondering if you guys covered it.
Oh, what would that chapter be called?
Uh, don't know. I'm bad with names. Okay, let's do this differently. The first one here. So just to be clear here, there are the three triangles. There's that one, and then there's the big one. That's the small, the medium, and the large. Okay. And the reason I bring that up is we have to make sure we know what it's referring to when we look at the question here. So let me grab this drawing one more time. So angle A and angle C, they are only part of the big triangle. So I would redraw the big triangle, A, B, and C. So if angle A is greater than angle C, then we know that the larger angle goes across from the larger side. Okay, so the larger side is BC, and we know that BC is greater than AB. Larger angle, and you had that correct there. And that's where I was sort of wondering if you had drawn these triangles. Did you like how did you do these, I guess?
Oh, so I didn't like draw it. Like, so if angle A is greater than angle C, then AB is greater than BC. Well, I mean, like, it just looking at it, you can know.
Okay, you can't do it that way. You have to figure out which triangle you're using, and that's I guess we'll look through. Like your answers might be right, but let's do it the way they want in the book, which is so angle A is up here. That's part of the big triangle, and it's part of the little triangle. A to D to B, A to D to B, that's part of the little triangle. So we know it's the little triangle here. So we know that, and sometimes it's good to draw the arrows so you know which one it is. We know that angle A is less than ADB. So then side BD is going to be less than AB. Is that okay? If angle A is less than that one, so then the side across from it is less than the other side.
Sorry, could you repeat that?
Yeah, you got to find since A is smaller than D, the side across from A is smaller than the side across from D. And the side across from A is BD. The side across from D is AB.
Okay, I see.
But again, like it's so this is true. I mean, you had true. And this one was false. I'm not saying you've got any wrong answers. Just want to make sure we know why they're right or wrong. Okay, let's try another one here. All right. If BC, so BC is this one right here. Could be the large triangle, could be the medium triangle. AC, okay, that's the large triangle. So you got to figure out that you're using the large triangle A, B, and C. So the other way to do it is to like use numbers. Let's just say B to C is like 5, then AC is 12, for example. That's another way to do it. So angle A is less than angle ABC. That is true. The smaller side is the smaller angle. Since BC is smaller than AC, angle A, which is across from BC, is smaller than angle ABC. This is actually true.
Hmm. You see. Okay, I see.
Got it?
Mm-hmm.
Okay. All right, ready for D?
Mm-hmm.
All right, ready for D. All right. So DC is part of the medium triangle, and it can only be part of the medium triangle. So we know it's the medium triangle. BDC. DC is greater than BD, so call this 8, maybe like this 5, just to show that it's bigger. And BC is greater than DC, so maybe call this 10. So then the largest angle is the one across from the largest side. That is true. BDC, B to D to C is this one up here. That is the largest angle. Largest angle is across from largest side.
All right.
So for part E, it's the big triangle that we're looking at. A, B, C, and it's always the case that the sum of the two sides has to be greater than the third side. That's the triangle inequality theorem. So all of these have to be true. They can never, 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 never equal the third side. It wouldn't be a triangle. All right, so number 6, we might need to look at your book.
Right.
I'm tempted to say that if the sides are unequal, then the angles are unequal. It's
Just real
like,
quickly,
yeah,
sorry, I didn't quite catch what you said about E. So is that false?
sorry, it is false. Yeah, I
Okay.
apologize. Sometimes I'm so indirect about it. I need to be more direct. It is false.
All right. All right. Let me look.
What is true is this down here. That's the triangle inequality theorem. That's what's true.
Yeah.
Okay, so for 6, it's usually like sides and then angles, or angles, then sides. So if two sides of a triangle are equal, then, well, the two, I guess, corresponding angles are unequal. Do you have your book?
Yeah. Right here it says, um, if if two sides of a triangle are unequal, the angles opposite them are unequal in the same order.
There you go. In the same order. So that's the whole like magnitude thing. Like they're bigger, then it's across from the bigger angle. If they're smaller, they're across from the smaller angle. Does that make sense?
Mm-hmm.
Okay. So for number seven, I want you to draw the triangle, and I suggest always drawing the triangles the same, even if unless you know something about them, but draw these all the same, or draw this triangle and just tell me where you label the vertices, which one is X, which one's Y, which one's Z, and then maybe you can answer the question without my help.
Okay.
How are you doing on this one?
I'm almost done.
Okay.
Uh, the largest angle would be Y.
So where did you put X?
Bottom right,
And then Y?
top.
Okay. So XY is 3, YZ is 4, and ZX is 5. Now this just happens to be a right triangle, but it doesn't matter that we've not drawn it that way. Um, so you said the largest angle is Y. You are correct. Good. Okay. Doing great here. Let's see if we can get to the turnover. All right, number 8. Can an exterior angle of a triangle be equal to either of the remote interior angles? So here's your exterior angle. Here are your other angles. I'll use A and B, the remote ones. Can it exactly equal those? And we did one just like this earlier where X was 120, which meant that this was 60. So what would that mean for A plus B?
B 120.
Be 120. So can it be, is that possible? Can A or B be 120
Like itself or added up?
itself?
No.
So no, they have to both be less than. So this is a no. No. All right. Part B. Part B is the triangle inequality theorem, which says that the sum of two sides must always be greater than the third side. So is this yes or no?
Yeah.
It's always true. Right. Ready to move on to 9?
Mm-hmm.
Okay. Hope this is helping. Do you have to take the test tomorrow?
Yeah, I think so.
Okay.
Or yeah.
All right. Always good to let me know that I kind of prioritize students that have tests. It's some urgency there. Okay. AB plus BC. So AB and BC are parts of this triangle. That's the triangle inequality theorem. So what's the third side of the triangle?
AC.
AC, yeah. Okay. The next B here, it says angle 4 plus angle 9. What kind of angle is that? You mentioned that earlier when we were talking about exterior angles. It makes a blank pair.
Oh, linear pair.
What is the angle measure of a linear pair?
180.
180, yeah. All right.
So yeah.
Angle, good.
So I was just gonna say, uh, it equals 180.
Yep. And there's a bunch of those in this drawing, as we talked about earlier. All right. Letter C. Go ahead and see if you can come up with that on your own.
180.
It's the sum of the interior angles. Good. So angle 4 equals angle blank plus angle blank. Give you a moment to think through that.
Would that would that be angle 2 plus angle 8?
It's the remote angles, angle 2 and angle 8. You are correct. Go ahead and see if you can work on the last one. I'm just going to step away for 30 seconds, but I'll be right back with you.
Right.
All right, I am back. Angle 7 is greater than angle what? And angle 7 is greater than angle what? That's actually sort of challenging. Um, kind of. It's the remote angle theorem.
Do you want me to find that in my book?
No, it's 2 and 9. It's back to this whole thing we were talking about up here with the exterior angle.
But like,
But,
couldn't it also be um oh
I mean, there's a lot of things like you could say it's for sure greater than 8. Um, but that's only because of the way it's drawn. So let's go with that.
all right.
Any questions, thoughts on that?
Nope.
All right. So the last one's a proof. They give you the step. So let's see if we can. They give you the statements and then there's the reasons. So we'll. All right. It's going to scale poorly, but that's okay. So that's your statement, and then you've got a reason. Whoa, 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 that was bad. All right, apologize for that. And then your reason here. What is the reason for the very first statement in any proof? At least one.
Given.
It is given. You always start there. All right, now next one, does this lead, does like A lead to 3? Um, is angle BAC less than angle 2 lead to angle 3 being less than BAC? Um, I actually have no idea. um, Angle 3 is less than BAC. BAC is less than angle 2. I'm not sure how to say it other than there's like a missing piece to it. So it's like, of course, BAC is greater than 3 because 3 plus something else makes it the missing length. But I don't really have a good explanation beyond that.
Trying to look at my book for Could it be related to the protractor postulate?
I couldn't tell you. Maybe ask your instructor. The next one's pretty clear from B to C. So B to C is that if you were to combine A and B, you would see that angle 3 angle is less than angle BAC is less than angle 2, and it's the transitive property. It's like if 2 is bigger than BAC and BAC is bigger than 3, then 2 must be bigger than 3. So this is I'll just say this is an ask. Could be. I don't know. It's like um it's pretty deceptive here. So then BD, which is across from angle 3. See how BD is across from angle 3, and AD, which is across from angle 2. That's the theorem we saw earlier where we said that if the two sides of a triangle are unequal, then the opposite angles are also unequal in the same order. I don't know how you say that, but it's, smaller angle, smaller side, larger angle, larger side.
Right.
I mean, it's theorem 13. All right, is it okay if we stop here for tonight?
Sure.
Excellent. Good luck on your test. I think you'll do okay.